This is section 3.1, and I've pasted questions number 21, 22, 23, and 24 on the board. I'm only going to do two, but I want to point out the similarity among each of these functions. And what they have in common is not that they are chain rule derivatives with an inside and an outside function, but that they are chain rule derivatives with an inside, a middle, and an outside function. So first thing I want to do is review how the chain rule works in that way. So say we have a function that is given by y equals f of g of h of x. Now, we want to find the derivative of this function y prime. Here's how it works. It's the chain rule again, but it's almost like you're adding a link to the chain. So there will be three pieces rather than two. First, differentiate the outside function f, leaving the middle and the inside alone. So f prime of g of h of x. Then multiply by the derivative of the middle function evaluated at the inside. So now we're looking at g prime of h of x. And finally, the derivative of the inside function. So we do just get an added link to that chain rule. So let's take a look at 21 and identify what those three functions might be. One good way to do that is to imagine that you're plugging a number into the function and then work inside out. So if I were to plug a number into number 21, it would go by the 3, where the x is, and the first thing that would happen to that number I plugged in is it would get multiplied by the 3, and then 2 would be taken away. So there's your inside function. The next thing we would do is take the sign of that number. So sine becomes my middle function. And then what we would do last is square the function. So the last thing that happens here is I'm going to say the squared is, let's do a new color. That's the outside function. So let's get on with dy dx. So dy dx in this case will be, first differentiate the outside, leaving the middle and inside alone. So 2 comes to the front. We leave alone the sine, which is the middle function. We're reducing that power of the 2 by 1. So now it's just sine to the first. We'll leave it, of 3x minus 2. Next, we're going to multiply by the derivative of the middle function, leaving the inside function alone. So now we're going to take the derivative of sine, which is cosine, and we're going to leave the 3x minus 2. And finally, we're going to multiply by the derivative of the inside, which is just 3. And then cleaning this answer up, the 2 times the 3 makes a coefficient of 6. And we have 6 sine of 3x minus 2 cosine of 3x minus 2. Let's do one more, and I think I'm going to pick number 24 here. So we have an inside function of 5x. We're multiplying the number we plug in by 5 first. We're going to have a middle function of tangent. So right after we multiply by 5, then we're going to take the tangent of our function. And then lastly, the outside function is the square root. And we may be helped if we think of that square root as being to the power of 1/2. So let's get on to 24. And we're going to write dy dx to say we're going to take the derivative. The 1/2 power is coming to the front. We're leaving the middle and the inside alone. So this is 1/2 times the tangent of 5x. And now that tangent of 5x is no longer to the power of 1/2, it's to the power of negative 1/2. Now we link up the chain. Let's do the derivative of the middle function. And we know the derivative of tangent is secant squared. So we got secant squared of, leave the inside, of 5x times, now finally the derivative of the 5x, which is just 5. So here's what we've got after we clean this up. The secant squared of 5x can stay in the numerator, as can the 5. The 2 is going to go down to a denominator. Then I'm going to take this tangent of 5x, which has an exponent of negative 1/2 now, drop it to the denominator so it's got a positive exponent, and I'm going to rewrite that as a square root since that's how the question was given. So we have a final answer of 5 secant squared of 5x over 2 square root of the tangent of 5x. And there we have an answer for 24.